The demand for energy is increasing rapidly across the globe due to population growth, industrialization, and technological advancements. Traditionally, fossil fuels such as coal, oil, and natural gas have been the primary sources of energy. However, these non-renewable sources are finite and have caused severe environmental challenges, including greenhouse gas emissions, global warming, air pollution, and ecosystem degradation. In response, the shift towards renewable energy technologies has become a critical step in achieving a sustainable future. Renewable energy harnesses naturally replenished resources such as sunlight, wind, water, biomass, and geothermal heat. Unlike fossil fuels, these sources are abundant, cleaner, and play a vital role in mitigating climate change while promoting energy security. However, while renewable energy offers significant benefits, it is important to acknowledge that it also carries environmental and social impacts that must be carefully managed. This discussion explores major renewable energy technologies and examines their potential environmental impacts, highlighting both their advantages and limitations. Solar energy. Technology overview. Solar energy captures sunlight and converts it into usable energy through two main approaches. Photovoltaic, PV, systems, which directly converts sunlight into electricity using solar panels. Concentrated solar power, CSP, which uses mirrors or lenses to focus sunlight and generate heat that can drive turbines to produce electricity. Environmental impact. Solar energy significantly reduces greenhouse gas emissions compared to fossil fuels and provides clean electricity. However, there are some environmental concerns. Land use. Large-scale solar farms require extensive land, which can disrupt natural habitats or agricultural land. Resource use. Manufacturing solar panels involves mining for materials like silicon, cadmium, and rare earth elements, which may cause localized environmental damage if not responsibly sourced. Waste management. At the end of their lifespan, 20 to 30 years, solar panels may contribute to electronic waste unless effective recycling systems are in place. Overall, solar energy remains one of the most sustainable and scalable solutions, especially when integrated into rooftops and urban infrastructure. Wind energy. Technology overview. Wind energy relies on wind turbines that convert the kinetic energy of moving air into electricity. Onshore and offshore wind farms are the two main applications, with offshore farms often generating larger amounts of power due to stronger and more consistent wind patterns. Environmental impact. Wind power produces no emissions during operation and is one of the cleanest forms of renewable energy. However, some challenges exist. Impact on wildlife. Birds and bats can collide with turbine blades, leading to fatalities. Careful site selection and new technologies, such as radar systems or bladeless designs, can help minimize this. Noise and visual impact. Communities near wind farms may experience noise pollution or object to the visual alteration of landscapes. Land footprint. Onshore wind farms require significant land, but turbines occupy only a fraction of the space, allowing agricultural activities to continue around them. Despite these issues, wind energy has one of the lowest life cycle carbon footprints among renewable sources and plays a crucial role in reducing reliance on fossil fuels. Hydropower. Technology overview. Hydropower is one of the oldest renewable technologies, generating electricity by using the energy of flowing or falling water. It includes large-scale dams that store water in reservoirs, run-of-the-river systems, which use natural river flows without large storage reservoirs, small-scale micro-hydro systems designed for local, decentralized power supply. Environmental impact. While hydropower generates reliable electricity with no direct emissions, its environmental impacts can be significant. Ecosystem disruption. Dams can block fish migration, alter river ecosystems, and affect biodiversity. Displacement. Large hydropower projects may force relocation of local communities and indigenous populations. Water quality. Reservoirs can cause water stagnation, impacting oxygen levels and aquatic life. Methane emissions. In tropical regions, decomposing vegetation in reservoirs can release methane, a potent greenhouse gas. When implemented on a smaller scale and with eco-sensitive designs, hydropower can be a sustainable energy option with minimal ecological disruption. Biomass energy. Technology overview. Biomass energy utilizes organic materials such as wood, crop residues, animal waste, or specially grown energy crops. It can be converted into electricity, heat, or biofuels through processes like combustion, gasification, or anaerobic digestion. Environmental impact. Biomass is renewable if managed responsibly but comes with challenges. Carbon neutrality debate. While biomass releases carbon dioxide when burned, it can be considered carbon neutral if new plants are grown to absorb the same amount of CO2. However, if deforestation occurs to supply biomass, the carbon balance becomes negative. Air pollution. Burning biomass can release particulates and pollutants like nitrogen oxides if not properly managed. Land and water use. Growing energy crops may compete with food production and require fertilizers and irrigation, which impact ecosystems. When based on agricultural residues or waste materials, biomass energy can reduce landfill use and provide decentralized renewable power. Geothermal energy. Technology overview. Geothermal energy exploits the natural heat stored within the Earth's crust. It is harnessed by drilling wells into geothermal reservoirs to produce steam or hot water, which can then generate electricity or provide direct heating. Environmental impact. Geothermal energy has a small physical footprint and provides reliable, constant power. Yet, it has potential environmental risks. Surface disturbance. Drilling activities may affect land stability or cause minor seismic activity. Water use. Some geothermal systems require water injection, potentially straining local water supplies. Emissions. While much lower than fossil fuels, geothermal plants may release trace amounts of gases like carbon dioxide, sulfur dioxide, and hydrogen sulfide. Despite these impacts, geothermal energy is among the most sustainable and dependable renewable sources, especially in geologically active regions. Ocean energy. Technology overview. Ocean energy harnesses the vast power of seas and oceans through technologies such as tidal power, wave energy converters, and ocean thermal energy conversion, OTEC. These technologies are still in the early stages of development but hold immense long-term potential. Environmental impact. Marine ecosystems. Installation of turbines or devices may affect marine habitats, fish populations, and sediment movement. Visual and navigation concerns. Offshore energy devices may interfere with shipping routes and coastal landscapes. Sustainability potential. Unlike fossil fuels, ocean energy produces no greenhouse gases during operation and has nearly limitless potential if technological and economic barriers are overcome. While renewable energy sources are not entirely free from environmental impacts, they significantly reduce greenhouse gas emissions, air pollution, and dependence on finite fossil fuels. Compared to the long-term damage caused by fossil fuels, the ecological footprint of renewables is relatively small. The key lies in responsible planning, technology improvements, and sustainable management of resources to minimize negative effects. Renewable energy technologies represent a cornerstone of global efforts to combat climate change, enhance energy security, and transition towards sustainable development. Each technology, solar, wind, hydropower, biomass, geothermal, and ocean energy, offers unique advantages and challenges. While they are not entirely impact-free, their environmental effects are far less severe and more manageable than those of fossil fuels. The true potential of renewable energy lies in integrating these technologies with sustainable practices, such as eco-sensitive site selection, efficient recycling of materials, and innovations that reduce ecological disturbances. When implemented responsibly, renewable energy not only helps reduce emissions but also encourages job creation, energy independence, and long-term resilience against environmental crises. In the coming decades, the continued expansion of renewable energy technologies, paired with policies and investments that prioritize environmental protection, will be crucial in creating a balanced and sustainable future. Ultimately, while acknowledging their limitations, renewable energy systems provide humanity with the most viable path to a cleaner, healthier, and more resilient planet.